Hey guys, it's Miss Aguilar. I'm going to go over this handout that you guys received the day after or the same day that we were doing the graphical representations of constant acceleration. And this is really an awesome little handout. If you have it filled out, then fantastic. What it does is it goes through and it gives you a starting position time graph. You can see all these ones right here. And it goes from constant velocity or zero velocity, right? All the way down to changing velocity, decreasing velocity. And then to the right of your starting position time graphs, it has velocity time graph, acceleration time graph, and then a written description. This looks a little bit different than what you guys have in the fact that I kind of put lines throughout the one that I initially handed out to you guys. All right, so I'm just going to go through and I'm going to fill in these as we go. I'm going to fill them in, and you should fill them in as we go, so you really have like a quick cheat sheet as you're doing the rest of these assignments. Okay, so the first one shows a position time graph that has a slope that is not changing. This is actually a zero slope. So if we have zero slope, that means our velocity is zero. So we would show that here. And if our velocity is zero, well, then we have no acceleration. Now, what you should do here is simply for each of these, write out what your initial position is, what your velocity is, and what your acceleration is. For our initial position, it's positive, and that's all we can say. And our velocity is zero, and our acceleration is zero. And now you can put in the units if you would like, but you don't have to. All right, how about this one? Well, we have an initial position of zero, so you can write that here. And our slope is constant and positive. So we have a constant positive velocity. Now remember, here, let me write this real quick before I say anything else. The only way we can have acceleration is if our velocity is changing, because remember, the definition of acceleration is a changing velocity, or the rate at which velocity is changing. So if we have a constant velocity, we cannot have acceleration. All right, next one. Again, we have a constant slope, but instead of a positive constant slope, we have a negative constant slope. And the slope on a position time graph is velocity. We have a constant velocity, we have a zero acceleration. Sorry, that's supposed to be straight. I swear I can make a straight line. They're both supposed to be straight. So whatever, I can't. So our initial position on our position time graph is positive. Our velocity is negative and constant. And our acceleration is zero. All right, next one. Here we don't have a constant slope. Here we have what we have been doing and what we did in the last video. We have a changing slope. But how is it changing? Well, put your tangent lines here. Starts off horizontal, well, more horizontal than it ends. So it goes horizontal to vertical, little vertical, more vertical, more vertical, really vertical. So it is an increasing positive slope. So we have an increasing positive velocity. So our initial position, 0 meters. Our velocity is positive and increasing. Please don't just put changing, because you can be specific. It's increasing. That's how it's changing. Now the slope of this line, remember, the slope of a velocity time graph represents acceleration. The slope of a position time graph represents velocity. Okay. The slope of this line is constant and it is positive. So we have a positive constant acceleration. Now, remember what I said about the same signs? Same, speeding up. Our object is speeding up, okay? Same velocity sign as your acceleration sign. That means that your object is speeding up. All right, so let's do our tangent lines again. it starts off horizontal and it gets more and more and more vertical. But this time, instead of moving in a positive direction, starting at 0 and moving away from your origin, we start at a positive position and move towards our origin or move towards 0. Okay, so we have an increasing negative velocity. Okay, so that's not such a great line. Let's try that again. Okay, let's try that one more time. That's a little bit better. All right, so our initial position, positive. Our velocity is negative and increasing. So what does that slope of our line tell us? Well, this is a negative slope, and it is a constant slope. So we have a negative constant acceleration. Same, speeding up. All right? Our object is speeding up in the negative direction. All right, last two. Tangent lines. Always start with a tangent line. It really does help you guys. And if you can see that this starts off vertical and gets more and more and more horizontal, yeah, those aren't not the perfect tangent lines, but if you can see that, then that's fantastic. This is a decreasing slope, and it starts at a 0 position and moves away from the origin. So we have an initial position of 0 meters. Our velocity is decreasing in the positive direction. So we have a positive decreasing velocity. So positive side, because that's what the positive sign means. And it's decreasing. So it starts at a greater velocity than it ends. Positive, decreasing. All right, let's look at the slope of this line. The slope of this line is negative and constant. So we have a negative constant acceleration. Negative and constant. All right, do you see the, oh, whoops, this should say constant right here. Our accelerations are all constant. Do you see that? Constant or 0? Meters per second square. So 0, 0, 0, constant, constant, constant. Because we are talking about constant acceleration in this unit. Okay, let's do this last one right here. Tangent lines. Sorry. Starts off vertical, gets more and more horizontal. So it's decreasing. So how is it decreasing? In what direction? Anyways, it starts off at a positive position and it gets closer and closer and closer and to the origin. So we have a negative decreasing velocity. So our object or our line on our velocity time graph is on the negative side and it's decreasing. So it starts at a more negative and gets almost to 0. So the slope of this line is positive and it's constant. So we have positive constant acceleration. Again, that's supposed to be a straight line. Okay, so let's fill this up. Initial position, positive. How do I know that? Look over here, starts at a positive position. This would be 0, this is positive. If this extended down, that would be negative, okay? This is positive, this is negative. Positive, negative, and that's the same way with all these graphs. All right, our velocity is, negative and decreasing. And our acceleration is positive and constant. All right, you guys, hopefully this helps you out. I definitely recommend keeping this with you. Fill this handout out and you guys will be good. It's like a little cheat sheet until you really get the hang of these. It's kind of a way just to check your work as well. All right, have a great day.